Okay, so we are going to solve the system using elimination. And, there's different strategies when you're doing this sort of thing. Just a question of what kind of comes to mind first. So the first thing I notice related to the first equation and the second equation, there's actually a lot of good stuff that's going on here. The first equation, everything is even. So what we could do is actually chop everything in half, divide everything by 2. And you could do that on the fly. In the second equation, everything's a multiple of 3. So why not divide everything by 3? This way we start off with something much simpler than what it was originally. So then we're not at a point where we need to worry about LCMs as much, because I can just negate one of the two equations, multiply through with a -1, and then add the two equations together. All right, when I do that, the x's are going to cancel out. 2y plus -y, or 2y minus y, will give you a 1y, or just y. And -5 plus 1 is -4. Now working with the simpler versions of the equation, I could take whichever one I think is easier to work with out of that. It does get a little messy, so you do want to keep things somewhat organized. Before I negated everything, it was x plus y equals -1, although you could work with the negated form also. So x plus -4, because that's what y is now, is equal to -1, which is the same as x, overshot the Mac, x minus 4 equals -1, add 4, and you get x equals 3. So now I have my solution of x and y being the same as 3 -4. All right, so word problems is really just applying what we were learning to a particular situation, but as we know from previous cases, we need to define our variables. So Lewis Carroll's Through the Looking Glass, Tweedledum says the sum of your weight and twice mine is 361. All right, and Tweedledee replies, the sum of your weight and twice mine is 362. Find both of their weights. All right, so we have two different people here. So let's let x equal Tweedledum's weight. So let's just say dumb weight. And y would be Tweedledee's weight, so we'll just say D's weight. All right, so it's a matter of perspective here. Tweedledum says the sum of your weight, so that would be Tweedledee's weight, and twice Tweedledum's weight, so twice x is equal to 361. And then Tweedledee says the sum of your weight, so that would be Tweedledum's weight, and twice mine is equal to 362. All right, so we have a little inconsistency with our variables. This is a question of which approach we want to use. I like the elimination method. Not everybody does, but it's my way. It's my way or the highway. No, it's really my way of doing it. I prefer that way. But maybe you don't. So if you want to use substitution, by all means, go for it. But I'm going to reorganize. So that the variables line up. I call that being stacked. The equations are stacked so that they have consistency in their variables. All right, so this would be my system. Now, it's a good system because all I'd have to do is multiply one of the equations. Let me get rid of that squiggly bracket. It's making a mess. Multiply one of the equations by -2, and I'll have a pretty good looking system here. So I'd be looking at, I'll rewrite 2x plus y equals 361, and then negative 2x, that would be minus 4y, equals 724, negative 724. Add the two equations together, and we're looking at negative 3y equals 361 minus 724, which is like negative 363. I don't know. Let me check in the calculator. Negative 363. So then divide, and we get y equals, it'd be 121. So we now know Tweedledee's weight is 121 pounds. So we just need Tweedledum. So let's choose an equation that makes it convenient to find x. I like the x plus 2y equals 362. So I'll pop in the 121 for y. That would be, what is that, 242? Subtract. Is that 120? Yeah, so yeah, x would be equal to 120 pounds. All right, so we just state our final answer, that the x, and we could just kind of note it off on the side here. Oh, seems like I'm doing a lot of stuff off on the side. So 120 pounds, use the pound notation, and 121 pounds. All right, so, you know, just do a spot check. The sum of your weight and twice mine. So 121 plus twice 120. So, yeah, that does equal 361. So it does seem to work. All right. In number 2, Ava tells her little brother Tony that she is holding 20 coins, all of which are dimes and quarters. They have a value of $4.10. She says she will give him the coins if he could tell her how many of each she is holding. What would you tell Tony to help him solve the problem? All right, so we have some dimes and quarters. So D equal dimes. You can go X and Y if you want, but I'm gonna spice it up a little bit. Quarters. All right, so 20 coins in all. All right, so the number of dimes plus the number of quarters is equal to 20. All right, so maybe, you know, be a little bit more specific. I might say number of. All right, and so in terms of value, I know each dime is worth 10 cents, so 0.10 times D plus 0.25 times Q is, so that'd be equal to, what was that, $4.10 is what they say. All right, so I just need to multiply, looks like the first equation by negative 0.10. So that's going to give me negative 0.10D minus 0.10Q equals, looks like negative 2. The other one, 0.10D plus 0.25Q equals 4.10. So that's fun. When you add them together, looks like we have 0.15Q equals 2.10 you don't have to put the 0 at the end of the decimal if you don't want to. It's just, we're talking dollars and cents. It just kind of feels better to have it there. So then I'll divide 2.1 divided by 0.15. And you get 14. So 14 quarters. All right, so that's getting us most of the way. 14 quarters is about, well, it's exactly $3.50. So just using your knowledge of dollars and cents, you can get the rest of the way. All right, so that's the same, and I don't want to penalize you for, having good number sense. So this is the same as $3.50, because every quarter again is worth 25 cents. So if I know I got to get to $4.10, that's 60 cents. If we're talking about dimes, then we're talking about 6 dimes. So 14 quarters and 6 dimes. But if you don't like that, you can just grab one of the two equations and plug it in. But again, I don't want to penalize you for, using intuition, because that's kind of what we're working towards here. So then number 3, find two numbers that such that the sum of the first and 3 times the second. All right, so I'll just stop right there. X is the first number, then Y is the second number. The sum of the first and 3 times the second is 5. The sum of the second and 2 times the first is 15. All right, so I want to reorganize. First one, I like the way it is. Second one, I'm going to rewrite as 2x plus y equals 15. Now let's multiply the first equation by -2. So we'll have -2x minus 6y equals -10. Second equation, keep as is. So we have, when we add them together, -5y equals 5. And then when we divide, we get y equals -1. So I just need x. So x plus 3y, I'll take that one. Really doesn't matter in this case, they're both kind of funky. X plus 3 times -1 equals 5. So that's the same as x minus 3 equals 5. And so x is equal to 8. All right, so I would conclude that my first number is 8 and my second number is -1. And we'll just do a quick spot check. What is this, Star Trek? Find two numbers such that the sum of the first and 3 times the second is 5. The sum of the first is, so if I add the first and take the second and multiply by 3, the second number multiplied by 3 is -3. Add it to the first, you do get 5. So pretty confident that I didn't just totally botch that up.